Hello again. In this video, we're going to talk about how we integrate sine squared of x and cosine squared of x. Now, we don't know the antiderivative of either one of these functions. So, in these cases, we replace them with trig identities. So, if it's sine squared of x, we're going to replace it with 1 minus cosine of 2x divided by 2 and integrate that function instead. If it's cosine squared of x, then we replace it with this identity, 1 plus cosine of 2x divided by 2. So notice the difference is this sign here. Then we're going to integrate that instead. Okay, so that's what we do in both cases, right? If you have either one of these indefinite integrals, we actually use these identities and integrate those instead. Okay, so let's look at one of these. Let's find this definite integral. Okay, so again, we're going to replace cosine squared of x with this identity. And then we can break this up into two definite integrals. And the way we're going to do that is we can break this up into two fractions. This denominator of 2 you can write as two fractions with a denominator of 2 in each of them. I mean, if these have a common denominator, you could write it as one denominator of 2, or you could break it up into two denominators of 2. Okay, so then we can break this up across addition, so we have two definite integrals now. Okay, so let's find each of these separately. So this one, you pull the 1/2 out since it's a constant. And then the antiderivative of 1 with respect to theta is simply theta. Then we need to evaluate this using the fundamental theorem of calculus. We need to evaluate it at the upper limit minus the lower limit. Now this is a special notation that says that. If you draw this vertical line and put the upper limit here and the lower limit here, then that means you're evaluating it at the upper limit minus what you get at the lower limit using the fundamental theorem of calculus. Okay, and then after we do that, we're going to multiply this by 1/2. Okay, let's do this one on the side. I'm going to evaluate it as an indefinite integral first. Okay, so we can pull the 1/2 out in front. And then to evaluate this indefinite integral, we're going to have to use substitution. Okay, since this is a composition of two functions, and we're going to let u be the inner function, which happens to be 2 theta. Okay, and now we're going to take the derivative of both sides of this equation with respect to theta. So that gives us du d theta is equal to the derivative of 2 theta with respect to theta, and that's equal to 2. Okay, and then you solve for d theta here. So just multiply the d theta to the other side and then divide by 2. And so we get d theta is equal to 1/2 du. Okay, and then we go back and we replace both of these equations into the original definite integral or indefinite integral. So d theta is 1/2 du, and then this becomes cosine of u. Then we can factor this 1/2 out in front. That gives us 1/4. Okay, and now the antiderivative of cosine of u. Now remember, derivative of sine of u is cosine of u. So the antiderivative of cosine of u should be sine of u. Plus some constant. And then we can replace the u with 2 theta. So it's 1/4 sine of 2 theta. Plus any constant. Now going back to this definite integral, This function happens to be continuous on this interval, so we can use the fundamental theorem of calculus to evaluate this. And we just need any antiderivative of this derivative of this function. And so let's just let c be 0. And use this antiderivative. Okay, so now we just have to evaluate that antiderivative at the upper limit minus what we get at the lower limit. Okay, so let's evaluate these. So this one will get pi over 2 minus 0 times 1/2, the upper limit minus the lower limit. Then this one, we get sine of 2 times pi over 2. Notice that the 2's will cancel out, and that just leaves you a sine of pi. Minus sine of 0, right, the lower limit. By the way, you can factor this 1/4 out. Okay? You could do it either way. You can think of this as having 1/4 in front of both of them. You're evaluating this function at the upper limit, and you get this, and then minus what you get at the lower limit, you get this. Then you would factor that 1/4 out anyway. So you can just also think of it as having a 1/4 in front. And then evaluate this at the upper limit minus what you get at the lower limit, which would give you this. So you can do it either way. Okay, so this lower limit, we get sine of 0, which happens to be 0. Okay, and so ultimately we get pi over 4 plus 1/4 of sine of pi. Sine of pi happens to be 1, so 1/4 times 1. And this happens to be 0. Okay, so we get pi over 4 plus 1/4. Okay, so that's how we evaluate cosine squared of theta. As an indefinite integral or a definite integral, we have to use this identity. And again, if it's sine squared of theta, then we have to use the other identity, 1 minus cosine of 2 theta. Over 2. Again, the only difference is this sign here. And a very similar thing is going to happen if you use this one. The only difference is you'll have a minus sign here. The first definite integral that you get here will be easy to evaluate, just like we did here. The second one, you'll have to use substitution, just like we did here. You pretty much end up with the same thing, except there's a minus sign here. Okay, so that's the only difference between the two. This happened to be sine squared of theta. Okay, but I'll leave that to you. These are special cases, but they're well-known special cases, so you should be familiar with them. And I'm sure you'll see some of them in the homework. Okay, so I hope you found this video helpful. Thank you for watching.